For number 33, it's asking us to find g prime of x given g of x. Okay, well, g prime of x, anytime you see f prime of x or y prime, g prime of x, that's a derivative. And we're going to learn how to take the derivative in an easier way later on. But for right now, we're taking the derivative using the limit as h approaches 0 of the difference quotient. So g prime of x will be given to us, let me make sure I'm drawing, by finding the limit as h approaches 0, in this case of g of x plus h minus g of x all over h. Okay, and so before I start plugging things in into that difference quotient, I'm gonna figure out what g of x and g of x plus h are. G of x is given to me the square root of 12x. Okay, and look, I'm gonna put parentheses, and you know what, I can make that look even better. It's the square root of 12x. Not much better. You can only do what you can do. I'm putting parentheses around that x. It's not really necessary, but it helps me whenever I'm finding x plus h, because watch, g of something equals the square root of 12 times something. Well, that something is x plus h. So g of x plus h, you're just going to put x plus h in the parentheses. It's not bad, okay? Which is, golly, 12x plus 12h. Okay, wow. Okay, so um, let's plug all this into the limit and difference quotient. The limit as h approaches 0 of g of x plus h is square root of 12x plus 12h minus f of x, which is just the square root of 12x, all over h. Whoa. So if I plugged in, and look, the limit is as h is approaching 0. If I plugged in 0 right now, I would get an indeterminate form. I don't want to deal with that. So what I'm going to do is keep working. I'm going to reduce this thing somehow. And a lot of times when you get an indeterminate form, you can factor, but in this case, I'm not going to. I'm going to multiply by the conjugate of what's ugly. What's ugly to me is the square root of 12x plus 12h minus the square root of 12x. The conjugate of that is the square root of 12x plus 12h plus the square root of 12x. What makes it a conjugate is that this sign in the middle changes, okay? Whenever I multiply it by the conjugate, this is what happens. The numerator, if you were to FOIL that out, multiplying it back out, would become 12x plus 12h minus 12x. It gets rid of the square roots because what you're doing, it's a difference of squares formula, really. I'm going to write it in a different color because I didn't really use it directly. But I took, I turned this into a squared minus b squared, because what I had was an a plus b times an a minus b, and so I turned it into this. See, here was my a minus b, here was my a plus b, so I just turned it back into that form where I multiplied it back out. Okay, and in the denominator, you're like, what good have you done? In the denominator, you have h times the square root of 12x plus 12h plus the square root of 12x. And you're like, golly, you've only made it uglier. Not really, because watch what happens. The 12x's cancel, and this h right here cancels with this one. And all of a sudden, I have the limit as h approaches 0 of 12. Oops, what a dummy. 12 divided by 12x plus 8, 12x plus 12h plus 12x. Square root of 12x, rather. And so if I perform direct substitution right now, which I'm about to, I'm putting that 0 in right here. This is my limit. 12 over the square root of 12x plus the square root of 12x, okay, which is, I'm simplifying it now, 12 over 2 square roots of 12x. I want to see if that square root of 12 reduces really quickly. The square root of 12, well, 12 is 2 times 6, which is 2 times 3. So the square root of 12 is really equal to 2 square roots of 3. So 12 over 2 square roots of 3, so it's 3x, and then this 2 multiplied by this 2 turns into 4. So all of a sudden we're dealing with 12 divided by 4 is 3 over, I put it times, 3 over the square root of 3x. Now you just want to rationalize because we don't like square roots in the denominator. So you multiply by the square root of 3x over the square root of 3x, which is 3 roots of 3x over 3x, which is the square root of 3x over x. Okay, that is the limit of the difference quotient as h approaches 0, so that's the derivative of that g of x. This is g prime of x right here. Okay, but what the question is asking me to do, let's go back to it. The question is asking me to, oh, it's only asking for g prime of x. So let me go back and look at it one more time because I've already forgotten. The square root of 3x over x. So let's turn it into a fraction. The square root of 3x over x. And there we go, people. Let me know if you have any more questions.